What is the slenderness ratio for buckling? Have you ever wondered why some structures fail under pressure while others stand strong? One key factor in this is the slenderness ratio, especially when it comes to buckling. So, what exactly is this slenderness ratio? The slenderness ratio is a vital measurement that helps predict how columns and slender structural members behave when they are under compressive loads. It is calculated by taking the effective length of the column and dividing it by its radius of gyration. This gives us a clear picture of how likely a column is to buckle. Now let's break this down further. The effective length is not just the physical length of the column. It is adjusted based on the column's end conditions, which can greatly affect how it buckles. The radius of gyration, on the other hand, relates to the shape of the column. It shows how the area is spread out around the central axis. You calculate it using the moment of inertia and the cross-sectional area. When the slenderness ratio is high, it indicates a more slender column. These slender columns are more susceptible to buckling failure, even when the compressive stress is below the material's yield strength. This makes understanding the slenderness ratio essential in design. Columns with a slenderness ratio above approximately 200 are considered long and need careful analysis to prevent buckling. From a mechanical failure perspective, knowing the slenderness ratio helps engineers predict buckling, which is a common failure mechanism in slender components. By calculating this ratio, engineers can design columns with the right dimensions and materials to avoid buckling and ensure stability. In practical terms, controlling the slenderness ratio can be done in a few ways. One way is to reduce the effective length by adding lateral supports or bracing. Another method is to increase the radius of gyration through better cross-sectional design, like using shapes that have higher moments of inertia. Lastly, selecting materials that are stiff enough to resist buckling is also important. The slenderness ratio plays a key role in using Euler's buckling formula, which predicts the critical load at which buckling happens. This formula shows that as the slenderness ratio increases, the buckling load decreases. This highlights the importance of this ratio in preventing mechanical failure due to buckling. In essence, the slenderness ratio is a dimensionless measure that connects the geometry and support conditions of a column to its likelihood of buckling. Understanding this concept is essential for preventing buckling failures in both mechanical and structural systems.